Okay, so it's 5:10. Our last speaker is Sang-Hyun Oh. He's now a PhD student in University of California, Merced. He's studied very interesting subject. It's kind of a relation between the poems and physics. And at this time, he prefers to talk in English to also to introduce the foreigners about our Korean poem. So please.
All right. Thank you for inviting for this seminar and talk. I wasn't expecting an invitation like this, and kind of funny how I got invited. So Professor Keun-Young was talking to me saying that, oh, we're gonna invite some diverse scholars, so don't be afraid. And I was like, okay, with other people I can do it. But like, I think I'm one of the most extraordinary or weird person with this topic. So today's talk is about Isang's poems and yeah, sorry, I thought I got a typo there, but it's not. So Isang's poems and the physics there, and it's for physicists. So long story short, I wrote a paper and it went viral, and then it's written for general public. But as a physicist, I wanted to talk with physicists as well, and I hope this talk to be a good opportunity for me to introduce some researches, and then maybe you can get some good intuition or I don't know, interest about the research. So the contents is I'm gonna begin with why I'm here today, talking about poems, and next short introduction about Isang, the poet, and then I'm gonna talk about physics concepts appearing in Isang's poems, because in some of his poems there were a lot of physics concepts appearing, but not many people didn't really know about it, and I didn't really know about it before learning about those. So I want to introduce some basic things there. And then I want to talk about my contribution. There are two sections, so poem titles and poem content. And then I'm going to conclude and talk about what's next. So why am I here? I already told you. I know it's a physics seminar. Yeah, I talk about physics. So I'm not a person who just sells like something else than physics. Okay, so I published a paper at August 31st. Actually later than that, because there was a typography issue because they wanted Hangul format, whereas I was submitting Word format, and the equations were broken, and then we had to replace them again, and it took a while. So it's not published in August, but anyway. And then it's quite recent. It's not been 2 months yet. And the title is like that in Korean and English, and it was published in Journal of Korean Culture. So so I got not me, but like our research got spotlighted by multiple news, my professors and my research. So there are multiple newspapers that covered our story and research, and we went viral on social media. So I didn't really know about the existence of this community. This is like teenager community called Doku, where people talk about idols, celebrities and such. And someone just put it there, put the news there, and then like the click number is 91,000 now. So like more than 90,000 people just saw that the news the person captured. And then there are some tweets here and tweet there. So as you can see, there are like 5,000 people shared the thing, and then 11K people retweeted the thing. So it got a lot viral than I expected. Some teenagers were afraid of this concept and this interpretation being on Korean SAT, Korean university entrance exam, and that's partly the reason why people were freaking out and then sharing the news. Anyway, it got popular, and then I actually made a YouTube video introducing the paper because I thought it would be a good way to introduce and communicate with especially general public, because it's easier to just click a YouTube video rather than like downloading a whole lot of paper and then start reading it. So I made that, and then it went good too. You can see there were like 20,000 views there. I didn't expect it at all, and then it happened, so I was like surprised, and my professor was surprised too. Anyway, if you want, you can go to the YouTube and then just find the video and see, but it's not in English, it's in Korean. So that's that. And then my paper got popular too, so 2,000 people were clicking the link and such. So today I want to talk about the poet Isang's and Isang's some poems and physics in it. So I want to clarify three things. First, poetic researchers already knew that there are some physics in Isang's poems, but general public didn't know. That's the reason why they were like, oh, I didn't know that. I didn't know that. Look at this research. But like my research is not about, oh, there is a physics concept. No, people knew already. But like I just contributed a little bit more on that side, on the science side. And second, so I talked three things all together. Cool. So I want to talk a little bit about the poet first. Isang's real name is Kim-Young. I wrote both in, not both, all in Korean, Chinese character, and English. And he used the writing name Isang, and sometimes some other writing names. And he's one of the most famous poets in Korea, partly because of partly because his poems are somewhat infamous by being very hard to understand. And he was born in 1910 in Korea, and it was under Japanese rule. So he lived the whole life under Japanese rule, and he died at Tokyo, Japan in 1937. So he died very young, like 27, 28. So he went to the best engineering school at the time. Now it's like Seoul National University Engineering School. So that 경성공업고등공업학교 became Seoul National University. And he majored architecture and graduated with honor, the first place. So he was quite a good STEM boy. So he knew about physics, he knew about mathematics, he knew about architecture. He was also interested in art, including literature and design. So he was able to do a lot of things. And he wrote many okay, so he worked as an architecture engineer for like 4 years at the government. He quit the job because of lung tuberculosis later, like 1933, and then he died like 4 years later. But like between those seasons, he wrote a lot of poems, novels, and essays. So now it was about the poet Isang, and now I want to talk about the physics concepts appearing in the poem. So I want to talk about the clear things first that everyone knew, like not everyone, but every literature scholar knew, so that you can feel that, oh, it's really about physics. So I want to show you two sets of poems. So this is the first set, 3차가 설계도, three-dimensional angle blueprint. I highlighted these three, Memorandum on lines 1, 선에 관한 각서 1, 2, and 5. So because they have the most things to show to you. And then there's another set of poems named under 건축 무한육면각체 building infinite-hexahedral-angle bodies. And there are 7 poems as a set, and I want to show you the first one as an example later. So I'm going from the apparent ones first. So this is the original version of Memorandum on lines 5. This one has like special and general relativity concepts. You can find physical speed limit, speed of light concept, time dilation and time traveling concept, and expansion of the universe, and maybe a little bit more. So on the left, it's like the Japanese language that Sang used at that point, because it was under Japanese control, and then like he wrote some poems initially with Japanese, but later in his life he wrote some Korean poems as well. But anyway, like his initial poems are in Japanese, and on the right I just highlighted some part. So this one talks about person, if the person is moving faster than light, what happens? We can go to future, we can go to the past or something like that. And then when you modify your velocity, something happens and such. So apparently it's about special relativity and maybe also about general relativity. And then in the middle, there's a expression saying, if you are worried about expanding universe, blah, blah, blah. So he knew about expanding universe things as well, Big Bang Theory, or not, maybe not exactly Big Bang Theory, but expansion of the universe. Okay, there's another one, Memorandum on lines 1. I want to highlight 3 concepts. The first one is dimension expansion by spectrum, but I want to talk it later when I talk about my research. So I'm going to talk about time traveling and electrons, protons, atoms we talk about. So on the left, it's like the original Japanese sentences, and on the right, you have the Korean translation. So it says like, there's a limitation on the speed of light. It's like per second, 300,000 kilometers, and then maybe human can go faster than that, then we can go to the past, something like that. So time traveling is kind of thing in his some of the points. This is the English version I found translation. One thing is that there aren't a lot of poems that's translated in English, so I want to talk about it later too. And then there's Memorandum on lines number 2. Okay, this is the original version. So you can see 3 plus 1, 1 plus 3. Every physicist student find it interesting because like space, time, 3 space coordinates, 1 time coordinate. It's kind of like, oh, I think it is that. You can just find it out that way. And limitation on Euclidean geometry here talks about those things. Okay, so this line, that line, and this line is like one thing, but I put like Korean version and Japanese version, but I couldn't find like the later part, the English version of the later part, so I couldn't put the English version. But anyway, it talks about 1 plus 3, 3 plus 1. There's 1 point on the line A, 1 point on the line B, 1 point on the line C, and A is the intersection of 2 lines. B is, oh, sorry, I had to, oh, so sorry. Sorry, I didn't change it. So it should be 세 선의 교점 B, 여러 선의 교점 C, and then intersection of 3 lines B. I didn't change it, sorry, there's a typo. And so this part talks about space-time, and in the middle it talks about Euclid is dead or something. So people think, like literature researchers think it's about Euclidean geometry is revealed to be not good enough or something. Maybe some people would interpret it a different way, but anyway, you can find some signals about his physics understanding. Okay, so now I want to talk about my contribution on Isang poem research, and it's about poem titles. So there are two sets of poems I showed you just now. One is three-dimensional angle blueprint, 3차가 설계도, and the other is infinite hexahedral angle bodies, building in infinite hexahedral angle bodies, which is 건축무한 육면각체. One thing is that in English, it's so obvious what it means, maybe, because that's my translation, because I understood something and then I translated it that way. But it's not necessarily that way. Some people translate different ways, like three-dimensional blueprint, infinite architectural hexahedron, things like that. So English translation is like has interpretation. Anyway, in Korean or in the Chinese character, it might not be that clear what it means. So I started my research journey from the first one, three-dimensional angle blueprint, 3차가 설계도. So the titles have been discussed in various literatures, but like nothing was complete. They were just talking about hypothesis, but like some people said, oh, maybe three-dimensional angle means like 3 dimension. And some people mentioned like, oh, 무한 육면각체. 육면각체 means 육면체. Like hexahedral angle bodies means like just a cube or something. They knew that it's not complete interpretation, so they were not confident. But it's been like that for 90 years. And many of them, like many of the researchers, have not thought about four-dimensional geometry. That's the reason why they couldn't reach to my interpretation, or I want to say like as a true or right interpretation. But anyway, so this 3차각, three-dimensional angle, it can be third-order angle too. It's like not that obvious which one it means, but anyway, if you think about three-dimensional angle, then we already know of two-dimensional angle from spherical coordinates. It's like theta and phi together. You can just call it 2D angle or solid angle. Then I was like, okay, what if we try another angle by talking about hyperspherical coordinates in four-dimensional space? Then you can find this kind of generalization. So left is just a spherical coordinates, and right is like four-dimensional spherical coordinate. So as you can see, there are just 3 angles, and I was thinking like, oh, that's cool. Okay, he talks about 4 dimension, he talks about special relativity, and 3-dimensional angle. That makes sense, because in 4 dimension you can have like three angles to locate a point. By the way, this concept can be thought as special relativity terms, and then can be thought as like Lorentz group and Lorentz boost, rotation, those things. But in my paper, I just talked about Euclidean geometry mostly, because it would be an overkill to introduce like special relativity to general audience. Anyway, that's what I did, and I was like, oh, that's cool, that makes sense, and I was happy. And I was looking up other things at that point, and then I found the relationship between this 3-dimensional angle and the other point set. So I was thinking, okay, 3-dimensional angle makes sense in 4D. What about hexahedral angle? 육면각. So if you are familiar with that name, you might be able to remember 이면각, dihedral angle. When you have like 2 planes meeting each other, then you can just define an angle between them as dihedral angle. And in 3 dimension, you can have another plane conjoining together to have like an angle, a point, pointy angle. So there's a term, trihedral angle, showing like that. So you have the, let's say this is the origin, 0 is the origin, and then you have like 1, 2, 3 vectors. Then you can span the vector space, or you can just make a solid in 3D. So you have three vectors to span, and in that case you can make 3 combination 2, which is 3 planes. So 1, 0, 1, 2, 0, 1, 3, 0, 2, 3 would be available planes meeting at the point 0. So this is an existing term that I didn't really know of, but it was there. So I was like, okay, that makes sense. Together, three planes meeting together. Then what about 4 dimensions? Then you can have 4 vectors spanning over a space, or making a solid there, and then you can just calculate 4C2 is equal to 6. That's exactly what I did, what I thought, and then okay, now 6 planes meet at one point at least, and then now it makes sense to call this as hexahedral angle, 육면각, because in that angle there are 6 planes meeting together. Okay, so after revealing those terminologies meanings, I was able to relate those 2 set of points. Before that, people didn't really think about relating them together, even though they had the angle thing together. Because like, if you look into the poems, their content is quite different. The first one, like 3-dimensional angle blueprint, that has a lot of science in it, but like the building hexahedral angle bodies, anyway, that one doesn't really have a lot of science in it. So people didn't really think about correlating them, but in the titles that people couldn't really solve like for 90 years, it was just like shown that they are related together. 3-dimensional angle is like just a like hyperspherical coordinates angles, and then in 4D, and then the hexahedral angle is like 4D angle in a solid. So nice. That was a great aha moment when I was relating them together. So now we can see that the first one is about blueprint in 4-dimensional space, time, and the later one, building infinite hexahedral angle bodies, is about building 4D bodies. So yeah, there was a relationship we found. And now I want to talk about not point titles, because I saw point titles, but about point contents. There are some interesting things in point contents, and I want to highlight 2 of them. So I already talked about the later part of Memorandum on lines 1, about just like apparent science on there. Now it's part 1, the part I didn't cover. And here you can see dots, a lot of dots, 10 by 10. And then here's the, so on the left, it's in Korean, and that part is here written in the original Japanese sentences and in Korean, in English. So as you can see, there is an axis XYZ. I was like, that doesn't make sense, because you have 2D here. It's apparently 2D there, and then why are you talking about 3D? And there was something here on the middle spectrum. So I was like, oh, okay, what happened? What happened? What happened? And then it became 3D. And thinking about spectrum, I was able to imagine this situation. So there are 100 dots, and then think of them as like some light coming out from a monitor or somewhere. And then if you measure the spectrum of each point, then you can get the spectrum of each point, and then you can put that on the z-axis to get a 3-dimension. And this was quite interesting. And then I was able to relate with other parts of the poem to support the idea of interpreting this spectrum as like dimension expanding spectrum. So there was a cool image I generated, and then cool topic, cool idea I thought of. And another thing on the content of the letter poem set, the building infinite hexahedral bodies. On that one, there is a poem named AU MAGASIN DE NOUVEAUTES. It's like French. And let's see. So it talks about a lot of different things. And the most supported so far interpretation about the poem is about it's about just a what is it called? Just a store with a lot of items that they want to highlight. Oh, sorry, I don't know why it's like going by itself. Anyway, but I just focused on the first sentence. 사각의 중의, 사각의 중의, 사각의 중의 사각, 의 중의 사각. So it means like quadrangles centers, quadrangle centers, sorry, my pronunciation is breaking. Anyway, like 4 quadrangular centers together and then another quadrangle. So I was like, okay, to understand this, we have to break them down to just like 2 of them. Quadrangle centers, quadrangle. What does it mean? 사각의 중의 사각. So so far people just thought of it as something like that. Okay, you have a quadrangle or a square like here, and then square inside as well. So they confine their understanding or interpretation in 2D. But I was, oh, sorry, I don't know why it's like going by itself. I was thinking that, one second, this one means like center, and then that one looks like the square's central line. Then why don't we try putting another square like that in 3 dimensions along the central line? And then I was able to draw another diagram showing that one. In this case, you had just like one quadrangle, and then now you are putting another quadrangle in 3 dimensions. So there's a dimension expansion from 2D to 3D. And if you add another quadrangle at the center, then it would mean like that. One thing is that if you are familiar with CAD, like computer assisted design, like 3D design tools, then you always see something like that because you have to draw the blueprint on the planes, and those 3 are like the main 3 lines there. So here now adding another quadrangle, you can see that the dimension should be increased to 4D for all the quadrangles to be at the center and then like actually orthogonal to each other. So, and then after making the dimension to 4D, it just stops and then talks about another quadrangle inside of that, and in that way, I interpret the thing as like you expand the space to 4D first, and then talk about other things in that space time or space. think that's like the essence of my research, and I'm quite perfectly on time to go to conclusion. Before going to the conclusion, if you want to ask any question, I'll take them.
이제 4차원에서 지금 평면이 어떻게 인터섹트 한다는 거. 4차원이면 평면의 인터섹션은 3차원하고 달라지는 건데.
그렇죠. 제가 이제 생각하는 것은 사실은 사각의 중에 사각이라고 했을 때 그거 어떻게 끼워서 중을 맞추라는 건지 저희가 없잖아요. 뭐라고 해야 되죠? 인스트럭션이 없는데, 근데 이제 그냥 임의로 그 사각형들이 서로를 수직 이등분하면서 올도그라게 만나는 걸 가정을 해보면, 그러면 이제 세 개의 사각형이 만나는 것까지는 아주 예쁘게 되는데, 네 번째 사각형을 더하려면 불가능해지잖아요. 근데 이제 그 전에도 계속 디멘전에 관련된 얘기를 하고, 디멘전 익스펜션에 관련된 다른 서포팅 아이디어들도 있어서 그러면 여기서도 디멘전 익스펜션을 얘기하고자 하는 것이 아닐까라는 아이디어가 넣고, 그랬을 때 이제 또 다른 사각형이 여기에 올토고널하게, 사실 올토고널하다는 게 잘 정의되는지가 저차원이면 노멀 벡터로 정의할 수는 없겠는데, 아무튼 유닛 벡터, 유닛 E1, E2의 outer product, E1, E3의 outer product, E1, E4의 outer product 이렇게 생각을 해보면 그것들이 이제 가진 릴레이션십이 있으니까 네 번째 사각을 더할 때 새로운 4차원의 축을 가정하는 것이 어느 정도 컨시스턴트한 해석이다라고 생각했습니다.
근데 지금 시간이 있는 4차원을 생각하시는 거죠? 유클리디안이 아니라.
그래야 할 것 같은데, 근데 이제 제가 생각하기에는 이상이 당시에 죄송해요. 이게 자동으로 자꾸 넘어가네. 이상이 당시에 지식으로 정확히 타임이랑 스페이스 엑시스 코디네이트의 차이점을 명확하게 알았는지는 약간 불분명한 것 같고요. 그래서 사실은 이제 논문에서는 이제 논의의 편의성을 위해서 유클리디안 지오메트리를 계속 가져왔는데, 근데 이제 실제로 더 엄밀하게 만약에 상대성 이론이 적용되는 뭐 민콥스키를 가정한다라고 하면 그러면 조금 더 복잡해질 수 있을 것 같습니다.
네, 알겠습니다.
So, any other comments? You may speak in Korean because this is thought. If you would like
혹시
to.
외국인분 안 계신가요?
Yeah, there are a few, but in case if you want to ask some questions in Korean, I think okay.
제가 하나만 질문해도 될까요? 그럼 결국에
예.
이게 첫 번째 문장에서 아까 사각의 계속 나왔는데 결국에는 이상이 생각한 디멘셔널리티가 어떻게 되는 거죠? 이 상황에서 지금 제가 결국에는 이 시의 첫 번째 줄이라고 해야 되나? 거기서 의미를 하는 디멘셔널리티가 어떻게 되는 거죠? 사각이니까 이게 몇 차원이 되는지 좀 헷갈려가지고.
네, 4차원에서 사실은 평면을 아까 기저 벡터로 생각을 해보면 총 6개가 중심에서 만나도 상관이 없는데, 여기서 관찰해보면 사각의 중에 이렇게 이어지는 게 총 4개의 사각형이 만나고 나서 띄어쓰기가 돼 있는 의중의가 있고 그 다음에 사각이 나오거든요. 그럼 이제 띄어쓰기 전까지 보면 3차원에서 막 4차원으로 확장이 된 다음에 여기다가 또 다른 사각형을 끼워 넣어가지고 5개, 6개를 해도 여전히 4차원일 텐데, 근데 그렇게 끼워 넣지 않고 여기에 분명한 띄어쓰기를 했거든요, 작품 내에서. 그래서 4차원까지 일단 공간을 확장한 다음에 4차원 공간상에 존재한 사각형을 말하기 위해서 저 의중을 띄어서 썼다라고 생각을 했습니다. 그래서 4차원이라고 보면 될 것 같습니다.
감사합니다.
Okay, so any other question or comments? Yeah, actually, I'm not a really big fan of Isang, but I didn't actually know he studied relativity, and in his poem, there's some ideas of the relativities included. I didn't know about that. It's very interesting.
Yeah, that's another reason why I was like very, very interested and at the same time kind of upset, because Isang is such a famous poet in our history and our like literature, and then like I didn't even know about he talks about special relativity. So yeah, that was an interesting thing to just to see. At first I kind of ignored his like sentences about science because I was just assuming he didn't really know much, but I feel like he knew just like good enough at that time, because it was like 1930, first, second, and then it was so hard for him to get such a knowledge, I think. And on the backup slides, I have some discussions about historical things, so I can talk about it too.
Okay, so any other question or comment? Yeah, then before closing, I would like to say one thing about Sang-Hyun. Actually, I'm very proud of Sang-Hyun. Sang-Hyun is one of the best students in GIST, I mean, my institute. And he graduated here, and he now is studying in the US. But anyway, so I think it's very interesting trial, and I mean, very meaningful in my opinion. So thank you for studying this. Okay, good.
혹시 질문 하나 해도 될까요?
예.
죄송합니다.
예, 좋습니다.
그냥 궁금해서 혹시 연구를 어떻게 시작하게 되셨는지 되게 저 개인적으로 되게 재밌게 봤거든요. 유튜브 영상도 챙겨보고.
네. 연구 시작은 이제 이 연구를 같이 출판한 교수님이 계세요. 이수정 교수님이라고. 그런데 이제 제가 1학년, 2학년 때부터 그 교수님과 친하게 지냈는데 항상 저를 보면 상균 학생 이상문학과 과학을 들어보는 게 어때요? 하고 이렇게 추천해 주셨거든요. 그래서 들어야지라고 하긴 했는데 이제 항상 물리 그 코스웍이랑 겹쳐서 못 듣다가 작년 봄학기에 졸업하는 학기에 이제 듣게 됐는데, 그때 이제 여유가 좀 있고 하다 보니까 좀 자유롭게 좀 자세하게 이제 들여다볼 수 있는 시간이 있었고, 이제 3차가 설계도를 꼭 해보면 어떻겠냐고 또 이제 요구가 아니라 권장을 하셔서 보니까 재밌는 것들이 있고, 이게 4디멘션에서 하이퍼스페리컬 코오디네이트를 만들면 3차원의 각도가 나오니까 충분히 재밌다라고 생각하면서 하다 보니 더 많은 것들을 이제 발견하게 됐습니다.
예, 개인적으로 그 물리학회지가 아니라 국어학회지 내신 걸로 알고 있는데 그 되게 인상 깊었거든요.
네.
예. 지금은 어떤 연구하세요? 그냥 이건 딴 질문인데.
지금은 여러 연구를 하는데 이상 연구도 아직 하는 중이고요. 제 대학원 연구는 이제 그래비테이션 렌싱 이미지를 가지고 모델링하고 피팅하고 이제 다큐멘터 모델 관련해서 검증할 수 있냐 없냐 뭐 이런 것들을 하고 있고요. 그와 별개로 아직 김근영 교수님이랑 연결이 돼서 그 머신러닝을 이용한 연구도 하고 있습니다.
네, 감사합니다.
네, 이 시를 쓸 때 이상이 일본에 있었습니까?
이 시를 쓸 때는 아직 조선에 있었던 걸로 제가 기억을 하고요.
그리고 제가 이렇게 인터넷을 지금 방금 찾아봤는데 허블의 결과가 1924년에 나왔던데 우주가 팽창한다는 거 어떻게 알고 있지? 한국에 있으면서?
그게 제가 조금 이따 히스토리 섹션에서 다시 말씀드리겠습니다.
아, 그래요?
그 뒤에 백업 슬라이드를 안 그래도 만들어 놨거든요. 궁금해도
아, 그래요? 흥미롭네.
그럼 뭐
conclusion.
지금 얘기해도 괜찮을 것 같은데.
네,
그렇군요.
네.
슬라이드를 빠르게 넘어가서 conclusion 그냥 별거 어차피 말을 다 한 거니까 넘기고 history. 일단 다들 아시다시피 special relativity. So as you know, special relativity was announced at 1905 and general relativity 1915, and then Eddington revealed that the sun mass can deflect the sunlight, the starlight at 1919, and then it got spotlighted by the media a lot. So from like 1919 and 1920, Einstein got a lot famous. And then at that time in Korea, there was a news that talks about Einstein and general relativity 1920. So this was from the alumni of the same school that Isang went. So Keung-Sung 고등공업학교 alumni had a kind of like newspaper, and then they already covered those news since like 1920. So and then there was Einstein's Japan visit, like he visited like 5 weeks. And then at that time, Korean newspapers covered Einstein's like history and Einstein's like, discoveries a lot. So 1922 and later, Korean newspapers like introduced his ideas, his travel, something like that, a lot. And then, as you can see, 2 poem sets, they were announced in 1931 and 1932. So there is a like 10-year gap. And I was curious about what happened during that 10 years. I mean, of course, he could have read something from 1922, but there can be a little bit of more connection. So what I found is that in Korea, there were like several people who really knew about like general relativity, special relativity, and then talked about those things. So one of the most important people is Keun-Sik. Keun-Sik, I think he was one of the founder of Korean Physics Society and like those things. So he's just a founder of Korean physics, I think. And then he worked as a professor at the same university, Keung-Sung. Oh, sorry, I changed the word order. It should be Keung-Sung 고등공업학교, not 공업고등학교. So I typed it in a wrong way. But anyway, at that same school, he studied from 1926 to 1929. So there's like 1 or 2 year gap between Isang and Keun-Sik. So and then the poems were released at 1931 and 2. So I highly I think it's very likely for Isang to have attended Keun-Sik's lectures or seminars, and then learned a little bit about like 4th dimension, and then some geometry there, and then special relativity concepts. But even without those those coincidences, Isang read a lot of books, both in Korean and Japanese, and he also mentioned that there's nothing to read in Korean, so I'm reading like Japanese things. So he read a lot of things, and he knew about a lot of things, I think. So so with those things, I think it makes sense for him to have known about some concepts and the Hubble expansion too.
Mm-hmm.
Yeah.
Okay, so any more question? Okay, then could you conclude, Sang-Hyun?
All right. So I wanna say what's next part rather than conclusion, because conclusion is a conclusion of the research, and the conclusion of the talk is what's next. So I think more physicists should join on like reading and maybe researching Isang's poems, and maybe we can make some puzzles by ourselves. So Isang released his poems on like architect, not journals, but like some paper things, and then maybe we can start writing some poems in Korean Physics Society paper, something like that. Even without that, we can try understanding some of Isang's poems. And one important thing is that he might have used like physical concepts as analogy or storyline, but so far, like literature research has not noticed a lot of them. For example, the title they didn't really know, and then on the inside the poems, the content, of course they found some, but like I bet there are a lot of things they couldn't see in their eyes. With physics eyes, we might be able to find more things and correctly. So that would be the basis of another research for them to do. Because with the right understanding about like basic concept and analogy, they might be able to find a better way of interpreting his poems in poetics. And I had some complaints about like copyright and then open source things and publication. It was hard to publish because they wanted like Hangul format, and I just wrote everything in Word, something like that. But like it's like complaints, so I just quit here. Thank you.
I have one question.
Mhm.
So you said you took a class in Isang?
Oh yeah, so in GIST, we have some literature classes, and one of them is Isang's Literature and Science. So I took that.
So I'm kind of curious how that class is built. That sounds like a very abnormal class to have. I think that's really cool. Like, is that person like literature professor in Isang or?
Yeah, so she is a literature professor. She majored modern poetics, and she is interested in Isang, and she do research. And I think one of the reasons why she made that class would be because it's GIST, the Institute of Science and Technology, so that science and technology people can go into literature and then see what they can find. And then actually like 2 years ago, 2019, there was one of my friends who took the class and then published another paper that wasn't that spotlighted, but her research was very good too. It's not about science, but more about like linguistic things that there are some linguistic puzzles too in Isang's poems. So she found a lot of them and then published it. It was really cool.
So is that the curriculum for that class? Does that just cover lots of poems by Isang?
Yeah, so we not only talk about poems, but also talk about essays and novels by Isang. And it's not about her teaching them. Rather, it's about students reading about his literature, and then we come together, we talk about our own ideas and our own interpretation, and then that's how the course is designed. In that process, I was able to find a lot of things too.
Good. So any other question or comments? So I propose to Sang-Hyun, instead of doing research about Isang, you may write your own poem based on your research.
Oh yeah, I was actually, I want you to introduce me to someone in 한국 물리학 so that I can publish my poems. I'm not sure whether they will allow that, but it would be interesting if I can do it.
Okay, we will wait. Okay, good. Thank you, everybody. So let's thank all speakers today. And I would like to thank all audiences for participating actively. Thank you. So is there any, so Professor Hyun-Seok Yang, is there
No,
anything? No?
여기 오신 모든 분들 다시 내일 뵙기를 바랍니다. We'll be back.
Okay, see you tomorrow.
예, 감사합니다.
Thank you.